Good day, everybody. I'm excited to present this video. I found a new source for functional equations. A gentleman by the name of Zhiqin. I probably butchering his first name. His last name is Lu. He's a full professor, I believe, at the University of California, Irvine. And I found a PDF that he had published dealing with solving functional equations. It's really beautiful stuff. It was out there for free. It's a PDF. I haven't met him, but I'd feel remiss if I did not credit this wonderful man for providing content for this video. Now, again, what we're trying to do here is find an unknown function from a functional equation. A lot of these have been published on YouTube sites where they do solve the functional equation, but they don't verify that it is a solution of the original functional equation. A lot of work is usually done just to get to that point, so a lot of people just quit. But I want to do both for you guys today, and I'll try to omit some of the details. I've written down a lot of the detail here, and I don't want to just, yammer on forever. But the idea behind this for this particular, and this is the problem function right here that I've highlighted. That is the problem equation, all right? And we're trying to find f of x. All right. Now, what really, it's a simple fact, but what really makes this thing fly is that 1 over x is its own inverse. In other words, the reciprocal of a number is just a number, right? So that simple arithmetic truth is what makes this thing fly. So you can see right here, all I've done is I've substituted 1 over x into the problem function, into the problem equation, right? And so you see, I just replaced x with 1 over x right there. I made use of the truth that the reciprocal of a reciprocal is a reciprocal right there. And of course, I replaced x with 1 over x right here. Now you'll notice here that all of a sudden after that substitution, it's very tempting to want to eliminate the 1 over x term. And you can use this elimination idea with abstract equations. They don't have to be a lot of scalars floating around or, what you're used to teaching in your college algebra course. We are trying to solve for f of x right here. So what I did, as you can see, and it's all written down, I multiplied this top equation by 3 in order to eliminate the f of 1 over x term. And you can see it all right here. It works out very, very nicely. When you subtract this bottom equation from the top equation, you get this statement right here, 8f of x, where f of x is literally unknown. We're usually used to working unknown as a number, a variable, and you're trying to get a number, but we're actually, the unknown here is an unknown function. And you solve for it algebraically just like you'd solve for anything else. Okay, but again, subtracting the bottom equation from the top equation results in this highlighted piece right here. And when you algebraically isolate f of x, you get this form right here. It's 9 over x minus 3 over x all over 8. Now, it turns out there's no need to simplify this. It is a function in its own right, and we don't have to spend any time simplifying it any further. Now, here's the part where most people just stop. But how do you really know that this function satisfies this original problem statement? How do you know? You really don't unless you check it. Now, one way to check is just to pick a number in the domain of the function and see if you get the same result. Now, that's technically is only a necessary condition. It's not really sufficient. But what happens here when we choose x equals 1, you can see right here, after you substitute 1 in to all these spots, you get 3 times f of 1 plus f at 1. That would be 4f at 1 equals 3. And so you get f at 1 equals 3/4. Okay, f at 1 equals 3/4. Now, that's just substituting into the original equation, okay? Without even having found the solution to this thing, if you substitute 1 into the original equation, we find that f at 1 equals to 3/4. Okay, now we're actually substituting the 1 into our solution. This is the answer to the question. We have found the function, so we think, and it's good news here because when you put 1 in, when you substitute 1 in, you do get 3/4. And I hope this green highlighting is useful for you guys. 3/4 right here, 3/4 right here. That is really cool. And again, a lot of people will, if they go this far, they consider this a proof. But it's really not even a proof. It's highly likely you got it right, but just checking for one value does not constitute verification. Now, what we can do right here, and I've done the work for you here, is you just take our solution. Again, this is our candidate solution, and we substitute it into the problem equation. And again, I won't go through all of these details, but you can check it out. And it's about collecting like terms and getting everything together, but it does work out. You get 3 over x, which is what you were supposed to get if you substitute the correct solution in. So again, this is exciting to me, guys. It's really interesting stuff where you actually are working equations where you're trying to find an unknown function. And one more time, I want to thank Dr. Honey, good God, sweetie. I want to thank Dr. Lu for graciously publishing all this stuff. It's been very, very helpful to me. I was having a hard time with this stuff. He published a really nice PDF file, apparently for everybody to access. I found it just by searching. So again, thank you for your time. I hope you enjoy.